there are many different aspects of network planning, management, verification that could be used. But I'm going to start talking about three specific parts that is probably the more important parts. And the first part is about the area. Whether we're building an indoor network or an outdoor network, we need to start with an area. If it's indoor, we have some layouts, we have walls and all the different things that we have inside the building. If it's an outdoor, we have our buildings, obstruction, trees, and everything. And this is very like the starting point. And the more accurate we be able to recreate that environment digitally inside the platform, that's a better start for building the network and basically having a more accurate, more successful project there. The second part is about the design, that there are different ideas there. Okay, design is complex and how it could be automated and how you could use AI. And we came up with understanding that where is that complexity? You have the coverage problem, you have the capacity problem, you have different types of use cases and demand in different areas. You have, for example, a warehouse, you have a lot of metal shelf in between. So it should be some sort of algorithm that be able to understand and adjust based on that. And then the last piece is you have designed the network, you have deployed the network, you did your site survey, you got the data back, and now you want to see how you did. And that's quite hard because there are basically many different aspects of your data that is collected that's different from the design and how we could basically use AI for that. And then when I talk about these three, after that, I do an end-to-end demo for three use cases. We build an indoor Wi-Fi, we built an outdoor private cellular, and then a fixed wireless. So you see how the workflow is going to be. So as I mentioned, the first part is about creating that digital twin. And why it's important because in the pre-sales activities, when a project comes that you're still not sure you got the project or not, you need to provide some sort of estimate. And you don't want to spend a lot of time there because you don't know if you got the project. But if you don't do a quite accurate design, that would affect the real design. And then once you get to the real design, then that's the time that you need to be really accurate. And it's key to make sure that the initial estimate and the final design are as close as possible. And we start thinking, how we could simplify this, that from the get-go, you don't need to have the most amount of expertise to be able to go and get the layout or get the outdoor area, but then it's good enough to be used for your final design as well. And there are three cases that I'm going to show there. One is that you have a layout for an indoor project and how you're going to do it with our workflow. Then you want to do an outdoor project and how you could use our data in terms of the clutter data, train data to make it happen. And then sometimes you have your own clutter data. You got it from some other LiDAR company and you'll be able to use it. So I'm going to go over here and show you a demo. So I'll start with the indoor. First of all, this is a SaaS platform, so you're able to basically run it on browser everywhere. And we start with an indoor. We generally start with a layout. So I upload the layout there. And basically, I look, for example, in this project. And let me show you that PDF. It's not a non-layered PDF. It has a lot of stuff in it. And generally, if you want to do it, you have to go and basically add all those walls and everything there. But let's see how we could make this smoother. So you upload your layout. And the very first thing that happens here is about the scale, because that affects how the AI is able to make things happen. And there's no clear scale information here. So what I could do is basically make an assumption that, okay, I have a door here. It's about 1 meter. Okay, that's fine. And then the second part is about, okay, where exactly is that area that I'm interested in? So basically, I draw a boundary and say, this is the area that I want the AI to analyze for me. And you click next, and you have basically this initial layout there. So you're able to go and draw your walls and everything there. But what we looked at is like, let's have this generate wall functionality from AI Assistant that you could basically click. And we developed a lot of image processing, a lot of different types of algorithm that be able to go and analyze this. And our platform tries to do it less than 1 minute, depending on the size and the complexity of that project and be able to fully kind of parse that for you. So I think this one, that definitely I did it before, it takes about 30 seconds to be able to see it. And yeah, and then I'll be able to show you what exactly I got there. So let me show this on 3D. Basically, the platform was able to generate all different types of walls that I had there and make assumption on their height, make assumption on the materials. And basically, you're able to go and see that, okay, the outer walls, it made an assumption that it's concrete. Inner walls, depending on the thickness, drywall, shorter, longer. And you're able to modify these easily. So if you're not happy with this assumptions, you could bulk change everything and basically you're done.
It did doors too, right?
It does doors as well, depending on the quality, it could change, but yes, it does doors as well, for example.
When you're doing this generate wall, how does the AI, like, what has the AI learned this from?
So we have trained a model with different types of layouts because, as you know, these are drawn many different ways. So we collected as many as we could, and we continue to do that. Somebody uploads something you've never seen, and our AI does 70% good. We train to make sure if another file comes there. So it's a continuous activity to make sure it works.
Only CADs, or can you take PNGs, SVGs?
At the moment, it works on all sorts of PDF and DWG files. We are going to have soon a version that works on JPEG and PNG. The problem with those is that it really depends on the quality. Sometimes it's drawn by hand.
How does it set the scale when you just have a PDF?
You have to.
I did it at the first step that said, this is my scale.
Have you found out how accurate that is? If you, I mean, a couple pixels on this could be.
Yeah, over a 1 million square foot first floor of a hospital is going to be tens of thousands of square feet.
You are able to change that, and then everything changes if you realize this is not correct. But also, if you have exact scale factors, then you're able to define that this is the scale factor there. So this was an indoor, but I want to show you an outdoor project. And basically, simply you're able to search or you go area. This is New York City that I'm from. Let's say we want to build a network for urban usage around Washington Square Park, NYU. So you just basically select that area and you draw a boundary around it that, okay, this is the area that I'm interested in. And you click next, and basically we go on from Google Maps and some other data sources, kind of capture that area. And there are a few types of information that we're interested in. One is the train data, that's what is the elevation of different locations that we have there, and then the trees and buildings. So we have this generate obstructions that you basically apply, and what it does, some parts of it is from data sources, some parts of it is basically our own image processing algorithm that goes and finds out whatever that exists there. And this is in 3D. See, you have these trees that are coming that has made an assumption based on their height. You have all the buildings there. Anywhere that trees were there, you're able to see, and you could see almost everything that was there. You got it. And certainly the quality depends on the area. We have tried many different places. We're very good in finding the footprints. That's whatever is in the footprint, we find it. We're good in finding trees. The elevation might be a little bit different, but those are the things you're also, we're working to improve, but also you're able to easily change them as well with all the assumptions as you have and different things that you have, you're able to make those there.
And the clutter data that it pulls, what it's sourcing it from, it's your own database, or I know you've answered this question for me in the past, but
there are different sources. Some of them are coming from public ones.
Like SRTM data.
Yeah, and some of them we do our own image analysis to be able to understand where different things are. Mm-hmm. So we realize it's very hard to find one source that has everything. And there are those sources, but they don't have APIs. You need to ask them to send you that data. Very hard to get that. But now with our platform, you just search everywhere in the world, and we're able to collect data from all sources.
And if we want to import our own clutter data, drone data, is it a standard open format for that, or what's?
That's my next one. So,
okay, sorry.
No worries. So the next thing is I have my own DSM DTM file, and basically I go and this is a format. It's a TIFF file usually that you have, and then a GeoJSON. that basically has the boundaries that, okay, this is my elevation, this is the boundary. I upload my DSM, and there's some standard ways, and that's how we built it. But that's something that is not super complex. Is if you bring some other data that's we haven't seen the format, we'll be able to adjust for that as well. And I upload those, and generally, it's a very hard job to be able to kind of put these on platforms. So we spend some time because these are built of 15 centimeters sometimes triangles that exist for different locations that the LiDAR has done it. So creating shape files out of it is quite complex job. And if you see now in 3D, it has created this place that has everything. And another thing I want to show you, we have this measurement tool that wherever you put your mouse, it says, what is your terrain level? What is your surface level? And see, like here, there's nothing. So there's 0 surface, but terrain is 22 meters. Here I have like nothing, but I go on a tree, I have 10 meters. So you're able to exactly see what's there and basically use it as if it's your PDF or whatever layout as you have and build your network there. So this is the first part. I'm going to go on the second part, which is about planning. So when we think about design, this is something more controversial because everyone's like, okay, you want to do design with AI. What does it mean? You want to say every 40 square meter, I want to go put an AP, but the use case is different. The frequencies are different. Wi-Fi 5, 6, private cellular. How does that work? And then you have different scenarios that one area you have more demand, one area you have less demand, one area you have more attenuation, one area you have less. How we could basically be able to address this unique environment and different use cases. So we spent some time and tried to come up with an algorithm, and we tuned it a lot to be able to address those cases. And I'm going to show you 3 of these cases. That one is like more normal case that you deal with, and then the other cases are more complex parts. And you'll see how this AI could basically help you out there. So this is the first example. Basically, this is a building of a dormitory. We used our AI to parse everything, and this was a better quality, so you could see that the doors are even there. And the first thing is always about the demand. So we created this functionality, generate demand with AI, and kind of collected different types of use cases. And when you click on that, it goes and assigns demand there. And you're able to see what's that demand. Basically, it's a dorm resident, and you're able to go and see all the details. That what are the assumptions for this? You're able to change it, use it, but once you trust that this is the right number, then you have assigned your demand for this area, and then you go toward the planning. So placing APs, first we're selecting, okay, what's the API I want to build this network, because everyone do it. I just make a selection. And you need to define a design criteria. Okay, I'm optimizing for 5 gigahertz, for example, here. I want to make sure I have minus 70 RSSI everywhere. That's one of my requirements. And I just don't want to do coverage. I want to make sure there's coverage, there is capacity here. And basically,
You have a requirement for no co-channel interference?
So we have SINR as well, that you'll be able to define what is your SINR, and based on that, it tries to do it. That's trickier, definitely, because sometimes you cannot reach that SINR with certain power levels that you have. So it does that, but it's not perfect, and that's something, gives you the base 80-90% design, and you might need some tweaking at the end. So it basically did this kind of initial design that tells you that, okay, for this place that is about 3,000 square meter, how many APs you need, how does it work in terms of capacity, how many users you have there, your drop off of the RSSI and everything there, generating your bill of material there, that, how many APs you have there, and you're able to adjust it and, add items to it. But I understand that this might be like a more basic type of thing. Say, okay, this is dorm residence. I know how much space there. I divide it and do that. So,
can you add IDF and run cable runs too?
We do have cable runs that we do, and we do have switches. We haven't put it in this version yet, but in the back end it has. We're going to show it in front end as well. But one idea is, okay, this project comes, you'll be able in a few minutes, be able to your initial design and be as accurate as possible. But let's see something that is a bit more complex here. And this is like a warehouse. And this warehouse, you have some shelves that are metal shelves, so the attenuation is not really continuous there. And they're in different heights, as you have there. And then you have different walls there. And you want to say, okay, what if I have this scenario? And this is not something like more that, okay, I put this many APs. This is more complex. You have to make sure things really work there. So I'm just going to show you how the platform basically reacts on this. So again, I provide a criteria and I would say, do this design. Here, I just do for coverage. And we have developed algorithms that is able to understand that, okay, these places you have more attenuation, these places you have more attenuation, these places you have more attenuation. So place my AP in a way that's, it's not just a uniform put there, it's basically changes it based on the properties as we have. So as you could see, like it has put it more APs around these areas, around these areas, around these areas. And here you have like more distance because there's less attenuation there. And it kind of understands these intricacies that exist there.
So when you say design for, I've heard you say design for coverage, design for capacity, and I just watched you do a demo where you did the design for, I think, coverage, and you used -70. Where are you getting those values? Where are you getting your cell edge values, your number of APs, your SNR requirements that our clients expect to see?
So this is what the designer puts in. So when a designer goes in and says, okay, I design a network.
So you're leaving that incumbent on the operator.
Exactly.
They need to know what the proper values are to plug in. Okay.
Yeah,
Thank
I
you.
mean, initially we didn't do it, and then nobody liked it. It's like, I want to say. So that's why we.
Or at least know where the data comes from, but okay.
Yeah.
Good.
Yeah.
Where did you get the input for the wall RF attenuation?
We do have a database that basically it has all these different materials, and then it does calculation frequency dependent. Here we just show for 2.4, but the backend understands that, okay, this is the material, and according to ITU standard, what are all the factors? And if I send a 5 gigahertz or 2.4 or a cellular, how much my attenuation per wall changes, and yeah, it does all of those calculations.
And once you've done the design, you've deployed, I think you said there's no validation piece as far as going out, doing an on-site survey and checking your assumptions.
So that's my basic next part, that, okay, you built this and you go your validation, you get the data and you want to compare. So I'm going to show that. That basically shows that step as well. But one other thing I forgot, so you're able to basically, change things and move around, and it's quite responsive. I mean, now the APs are connected together, but if I delete some, you could see that, you could move and then it changes right away. So if you want to do small modifications, it happens quite faster. The next example, which is a bit different, is about different demand, because then this is an outdoor project. So on this outdoor project, if I have my areas, I have 3 different areas that here I have autonomous devices, but here on these places, it's much lower demand. And I have defined these before, that what is the definition of lower demand, what's the definition of like autonomous devices. But I just want to show a scenario that you don't have uniform demand everywhere. It's not about attenuation. And the platform understands as well. So, I could go here and say, okay, now go for this scenario, and maybe this time I do a cellular because it's outdoor, and I pick a Salona, and again, I define a criteria and say, okay, now design for my both coverage and capacity here, and analyze that I have more demand in this area, I have less demand. And this is the focus is just on the outdoor. It doesn't try to build things in the indoor.
Do you find a lot of people asking to do simultaneous private LTE and Wi-Fi design, like at the same time on the same map for the same deployment? Like my engagements are usually, we're doing Wi-Fi, and then separately there's private LTE, and they never want to see the two mashed together, right? They're completely different.
Yeah. So
I'm just wondering about the use case,
Yeah,
right?
yeah. I was actually talking to someone last night, and they were telling me, what if I could basically on one place be able to say, I build it with Wi-Fi, I build it with cellular hard disk, or I'm gonna basically look at different coverage maps. So they are the ones that are closer to my Wi-Fi. These are the certain applications, and then the ones that are much further, I support them with my private LTE because Wi-Fi doesn't reach there. So I'd be able to, in the same place, have some of my applications that are further on my LT side, some of that are closer on Wi-Fi. That was one of the use cases he was talking about here. But another use case that we've heard, still private cellular is a new thing. So sometimes the customer wants why, and then you'll be able to build with both networks and say how many APs you need if you do with the Wi-Fi, how many APs you need if you do private cellular.
But rarely the use cases are the same, right? I've never had a customer come to me and say, hey, here's my singular use case, and I feel like it can be addressed with either Wi-Fi or private LTE, no big deal. Pick one, right?
Yeah.
It's usually I've got an application, and that application lends itself strongly to private LTE or Wi-Fi. Yeah. Does anybody regularly compare the two from a sales effort?
We spoke with people who were more on the private LT side. When we were talking to the enterprises, the first question is like, why should I even have private LT? Why should it, Wi-Fi is doing it for me? Why? And they needed to be able to find a way to tell them that, okay, for specific applications or the way the design changes, how you're going to see how many APs you could, put on Wi-Fi versus how many on cellular, and then you be able to make a more informed decision. Not that to just prove which one's LTE is better, maybe Wi-Fi is a better solution, but be able to just show them that decision in with few clicks. So when I make a decision, I feel better about it.
Okay.
All right. So considering time, the next thing I want to talk about is the validation side. And this is the much harder part because you build the network, you collect your data, and it's very hard to compare because the data that you have collected is basically might not be as granular as you had it in your design side. They might not even put the APs exact same place, and you're not sure how exact it is. The environment might have stuff there that there was not in design. And when we spoke with people, they told us that it's a lot of hard manual work that I need to go and look and try to find out. So we start thinking, okay, how we could make it easier. And the second part was that in the outdoor, in the cellular side mainly, there are different devices that you're able to go and measure, and there are a range of devices that are there. And you export the data from those in different formats. And what we try to be able to kind of load them in. And as we kind of build these partnerships, be able to have more and more devices supported. So it's not really say you have to use my device for your own validation and site survey. Collect your data from any device that you want and just load it to our platform. So this is still like a beta version. So I'll tell you that, but let me show you what's the idea here.
So following up on that, on the Wi-Fi side, then what tools are you supporting? What physical tools to go do those measurements?
So Wi-Fi is much trickier because they're way more closed in that sense, and they have their own.
Exactly what everybody here is interested.
We're asking,
yeah. So I had a conversation with the team at Open Intent, Jake Snyder, and we proposed to them, what if we have open survey? What if we be able to define a schema that everyone could put their data in that schema and export it? And when people say, let's be able to move the design between different platforms, I think it makes sense to be able to move the validation as well. And we certainly support that. There's so many different tools, and we're not thinking of make another new tool. So now people have one more. So that's like idea we have. And if people be open to just export in CSV, that's we could do. If they could do KML, KMZ, we're able to import our platform. But having that standard schema, I think, is key to give the user the flexibility that I want to use whatever tool I want. I shouldn't be forced. So yes, Rocky, it's hard in Wi-Fi side. At the moment, our focus is outdoor and private cellular because that's way more open.
Yeah, so kind of like in private cellular where you can, I can use different tools, but they all allow me to, for example, export it as like a CSV or Google KML file, and I can just, hey, here's the file, process it, map it out for me, and all that. So open intent, some similar concept where here's the file and just map the data.
Exactly. Yeah. So this is. I'm just going to turn the heat map off. This is an area that you could see in 3D. That this area I have my elevation. I have some of my obstructions here, and basically I needed to design with this is my design. I have like 3 APs and I put them here, and that's how it looks like, my heat map. Then I have uploaded 3 different site survey data, well 2, but I could show you how it's basically done. You have these CSV files, and these CSV files, if you go inside of them, has lat long values, num of AP, and as long as this format is there, lat long KPI, you're able to put it in our platform. And you basically add it, and you just say, okay, I'm doing for this specific band, because we'll be able to match what band it is based on the design. And once you do it, you basically have it here. So this is my design, and then this is my site survey. And the same thing here. This is my site survey, this is my design. So there's a bit of difference there. And we have done some interpolation to make sure that the data matches. If you go a higher resolution, then becomes dots, because I don't have that data.
What's the blast radius around each of your dots?
I think in this design that's coming there, JT, I think you're there. You could tell me it's a few meters, right?
It depends on the size of the layout. So
No, the site survey data that we uploaded, not the design.
I'd have to check on the exact resolution of that, but yeah, it's a roughly similar to the resolution that you see on the screen here.
So each dot has a KMZ with a lat long, and then it has a 4-meter diameter. Or
we made the assumption. So if we increase the resolution, that's how it's going to look like. So it's basically those points, and if you go further resolution, then it becomes smaller. So we made an assumption that, okay, if I have a data in this.
How did they collect all the data points in the water?
Oh, this is some basically synthetic data. It's not. You didn't go exactly do that. Yeah. Yeah.
So it wasn't collected data.
Yeah, it was basically got some data, manipulated it, and then put it there. It was not like we didn't go on these places one by one, basically do that there. But it's the same format as you could basically bring in anywhere. Here, the idea was mainly show you what we were able to do once the data is there. So,
and you have a differential?
Yes, so that's the idea exactly, to be able to create that differential. So you have this concept of validate design, and once you run it, it creates this kind of differential. And this differential, what it does, is, as you could see, the green is basically within 20 plus or minus, but you could see exactly how different it is.
20 plus
dB?
Or minus what?
dB.
20?
Yeah, but this is just show, but you could see the exact values here. See?
I'm sorry. That just was shockingly high amount of dB for.
Exact values are here, so you could see this is just like a heat map. So you see it's -8, -7, 12, 14, 3, -2. So we do have the exact value there.
So green doesn't mean -20.
Sorry.
Green doesn't mean it's within 20.
It's green means it's plus -20, but we have the exact value there. It's just the coloring.
Oh, okay.
Yeah.
But you can adjust that.
Yeah. It's just for demonstration of the.
And it's just using the design as the baseline, or is just saying what I measured is within 20 dBs of what was designed originally?
It's design minus site survey point by point.
Hmm?
And based on this difference, basically it runs some algorithms. And here, number 3, which is this AP, it says incorrect power. So the power levels were different. So here you see it's like -8, 7, 6 difference there. But here you have like much less there. And you could basically see here that here I have much higher power here. And then if I go here, my power has decreased. So basically, it's able to do those kind of basic analysis. That's okay. What are the problems you might have? Is my AP the same location? Yes. If it's same location, do I have the same power? Yes or no? If I don't have the same power, do I have the same pattern or not? If I don't have the same pattern, maybe there was an obstruction that I missed in my design. So it is able to basically do these three things. And as I said, this is an ongoing effort because there's various reasons that could be there. So we are working on this. So for example, here it says missing obstructions because there were these obstructions did not exist in that in the design that was there. And then the last one, I think, is number 1. It's the correct power. Number 3, incorrect location. So number 2, if you look at here, the peak power is here, the peak power is here, and then if I go, it moves to here. So it kind of does the comparison, say, okay, I have the same pattern and it has moved. And as I said, this is a beta version, but we think there's a lot could be done here using AI to compare the site survey data with the validation to make part of this manual work that you need to go see it, be able to automatically do it there. So considering we have only 5 minutes, I wanted to do 3 different use cases, but maybe I start with basically a fixed wireless because I talked about everything. I didn't talk about that. So in the fixed wireless design, I use that DTM DSM file that I put there. So basically I have the details about all the terrain and elevation as I have there. And I'm able to, I know that where is the location of my transmitter. So I define my transmitter here. It's a Tirana's transmitter. I know I could have max ERP up to 50, so I put like 500 milliwatts. It's 15 meter high, and then I know the antenna and the azimuth and everything. And I know the location, so I just put it there. Sorry. And I think I know my azimuth, for example, is 200. And the azimuth gets updated. So now I have basically my general kind of heat map. That's how the signal is going to be perceived with all these different clutter that I have there. We have this feature of fixed wireless. So you say, okay, this is my transmitter and I have specific receiver. I use the Tirana again, and it's, for example, 3 meters high. One thing you could do is you'll be able to do a line of sight analysis. You'll be able to move around your AP and then see where you have your line of sight, what's your Fresnel zone analysis, all the details of clearance and everything. That's one side. But if you know already where exactly you want your receiver to be, for example, you know that you're going to put your receiver here because that's the location that you have. So let me put the heat.
Is here with Tirana, are you taking into account all of the antenna, the beamforming that they do, and all the phased array stuff? Or are you?
No, this is the antenna pattern in terms of power and the line of sight to just have it from the transmitter.
But it doesn't take into account Tirana's phased array?
I don't think so. Right, JT? I don't think we have phased.
Well, yeah, I mean, we use an assumption on essentially what the peak receiver gain and then obviously the directionality of the transmitter.
Okay.
So yeah, I mean, we boil it down essentially to the combined gain and the link budget, but we aren't doing anything with sort of how they do it with a phased array. I don't know if that would add any detail that would be relevant.
Well, it'd make it better. Like it makes it way better, but
yeah, I mean, in this case, we're sort of assuming that
just power, just raw power, antenna, etc.
Oh, we got bad Wi-Fi.
Lost there. I understand. Yeah, it's
So I don't have any clearance, so I could play with the height and basically go up and say, okay, I need to go up. Now I have like 0.9 meter. Okay, at 10 meter, maybe, okay, I get 1.3. This is what I received. So you could go around the Z direction and then see how the power changes. It considers both the transmitter and receiver power. And then I'm able to download basically the analysis and see, okay, this is my transmitter, this is my receiver, this is my train. And these are all the clutter that I have in between. And this is my basically R radius that I have. So you'll be able to do a direct point-to-point analysis. There, or if you have multiple receivers, you'll be able to compare that as well. And that's basically to bring in internet to that place to start. So that's one example. And then
to confirm, the target is a CSP. They would be the ones who would use this primarily.
We have seen many different applications. For example, you're in the middle of a park and you want to provide internet. So point to point, you have your transmitter.
So the park is actually implementing the FWA themselves.
Yeah,
Okay.
yeah, exactly. Yeah, that's one of the.
Pretty neat.
Yeah. And
anything on the roadmap for integration with the vendors, so you'd be able to, if the design's in here, to push it out to the cloud?
Yeah. So it's just a matter of doing APIs. I mean,
Okay.
Mist, many of them, they have those APIs and you're easily able to go. So it is on our roadmap and we definitely want to do that. Because the idea is your design, you deploy, you get your site survey data, and then you'll be able to also get real data coming from your deployments and be able to compare everything together, or be able to push your design, say, okay, these are my configurations, just go and deploy it for me and make it happen.
Okay.
Frequency set, you guys are doing CBRS. Or
We do every frequency, to be honest, but the APs that we have CBRS for LT 5G, and we do 2.456 gigahertz. But the core ray tracing model that we have is able to handle that's
Whatever it is.
Yeah, any
2460 is already included too.
sorry.
24 and 60 gigahertz.
Yes, 2.46 and then
No, 24.
24.
Yeah.
24 gigahertz.
Yeah.
Ubiquity.
The ray tracing is able to do it.
Yeah.
I don't think we have those APs specifically in the platform, but that's something we could add.